All right, trying out the today's daily problem. It's called daily temperatures. Given an array of integers, temperatures represents daily temperatures. Return an array answer such that answer I is the number of days you have to wait after the ith day to get a warmer temperature. If there is no future day for which it is possible, keep answer if I equals to 0 instead. Okay. So for example, in this case, 73, I have to wait one more day. Yeah. And then for 7. So basically, the next greater element, right? Essentially, that's what this problem becomes. You have to find the, for 73, the next greater element is 74. For 74, the next greater element is 75. For 75, the next greater element is 76, which is at this next. So you have to find the index of the next greater element. So the problem is find the index of next greater element. Okay, how can this be done? No, it's a difference between maximum element on the right, because if you were to find the maximum element on the right, then it would be probably easier, right? Then you could just maintain a max, and max seen so far would be the maximum element. The next rate. Could I just do like that? So if I move from left to right and I maintain just a max, well, that's not necessarily the case, but uh, so okay, so let's say 73, and then 73 is the maximum element, and then 74 increases, so 74, and then yeah, but you need to find the next letter for each element. How do you do that? Okay. Uh, Obviously, this is a typical coding problem. I just won't recall. I know you can use a stack or something. Uh, let's try and frame the solution. So for 73, the next greater element is okay. For 75, the next greater element is 76, which comes here. So if I am going from left to right, let's say I'm going from left to right. So I take a look at 73, then I get 74. Obviously, 74 is the next greater element for 73. So that's done. For 74, 74 again, 75 next greater element for 74. So that's done. Now I have 75. Then I get 71. I don't care about 71. So I have to keep track of 71. 69, I have to keep track. 72, I don't have to keep track because, okay, so this is the thing. So for 72, for how many elements is 72 the next element? For 69 it is, for 71 it is, for 72 I have to find. So I maintain a stack. I go from left to right, I maintain a stack, and this is what I do. If my if my stack is empty, I just push my current element to the stack. Okay. If my stack is not empty now, then the element that I'm looking at right now is that element uh, till that element is greater than the stack stop element. Keep on popping elements from the stack and assign their next greater. And assign it. So I have to maintain indexes maybe then. Sure, you have to maintain maybe indexes or the values, and then uh, what exactly? And then push this element onto the stack, right? So yeah, so 74, 75, and then I have 75 on the stack, I have 71 on the stack, I have 69 on the stack, and then when I get 72, I'll pop out 69 and 71 and push 72 on the stack. Then I get 76, I'll pop out 72 and 75 and have 76 on the stack. Then I'll have 73 on the stack. At the end of it all, the elements that are left on the stack, for all of them, the answer would be 0 because there is no next greater. It's as simple as that. Okay. So you get your stack of, first you want to delete in integer array, daily So just call it next greater, yeah, or wait. Let's call it wait. Okay, so wait equals to a new integer array of temperatures dot length. Now your stack of integers, stack equals to a new stack of integer. So int I equals to 0, is less than temperatures dot length plus plus. Okay. Now if stack dot is empty, then you simply just add I. That's it. Else, if stack is not empty, then while this number, so while this temperatures of I is greater than stack dot peak, no, but you also have to do and stack is not empty, right? Because you're popping it out. If stack is not empty and this, so I'm guessing this can be even put beforehand, right? So let's do this, let's do this, let's do this, and remove all of that. So while your stack is not empty and your temperature I is greater than stack dot peak, then you do what? Then you do weight of stack dot pop. Okay, so x equals to stack dot pop, and then weight of x equals to number of days to wait is I minus x, right? I minus x. Now, once you're out of this, that means either your stack is empty or your temperature is not less, right? Either of the two cases. In both the cases, you have to do stack dot push I. Either your stack is empty or yeah, and so this is the thing. Okay, and I think at the end the remaining ones will have weight as 0, and integer in Java already gets initialized as 0, so you maybe don't even need to do anything further. Just do uh, return of weight. So overall the time complexity will be definitely linear. Okay, the answer is wrong though. The output is all 1111. Let's see again. 73, 74, 75. This makes sense. For 75, why would okay? Let's think about it. So you're pushing I. So first thing when it will happen is you'll just push uh, 0 into the stack, and then the rate of 0 would be 1. Stack is not empty, but stack is empty now, so you'll get out of the while loop. You push 74, 75. Okay, okay, yeah, I got it. All right, run code because you're saving indexes. Yeah. Okay, let's submit. All right, now let's talk about the time complexity. I mean, if you look at in a very naive form, we'll see there is a for loop and within it there is a while loop. So does that mean the time complexity is n squared? The answer is no. The time complexity is O of n, and let's see why that is. Or let's try to understand why that is. So how many times an element is inserted into the stack? Let's talk about that. So what will be the worst case input here? The worst case input here would be this while loop runs a lot, right? Because this for loop is always going to run. So you want to make this while loop run a lot. When will this while loop run a lot? When your stack is not getting empty. But how can that be the case, right? Uh, so let's take these two cases. One is increasing because I think one of them has to be the worst case. So 1, 2, 3, 4, 5, or 5, 4, 3, 2, 1, right? So in this case, what will happen? In this case, so let's here this is stack, right? So outside for loop is fine. Inside for loop, how many times the while loop is running? Let's see. The while loop for here. First, okay, it will just push stack into the stack. Then in this case, you will see for two, uh, it's exactly one, right? Because there's only one element, you pop it out. There's only one element, you pop it out. There's one element, you pop it out. So this while loop is actually exactly because your stack only has maximum one element at the time. So, or rather, to look at it another way, how many maximum number of time, how many in total, right? In total, how many elements will be inserted into the stack? Uh, and or each element will be inserted into the stack at most one time and removed at most one time, right? So at most will be two of n. So for example, which will be this case. So in this case, what's happening is within the for loop, you are just doing one pop and then one push. Within this, you're not within this while loop doesn't run at all for any of them except the last guy, right? Actually, for none of them, right? Here you'll do is you'll check this condition. This condition will never meet, so you'll just keep on pushing it to the stack. So you'll have your 5, then you'll have your 4, then you'll have your 3, then you'll have your 2, then you'll have your 1, and that's it, right? So you can clearly see this overall when you look at the final thing. The maximum the stack can grow is up to size n, right? So to your at max, we are inserting one and pushing element once in the stack and popping it out. So your time velocity overall is still like 2n or which is essentially linear. All right. So I don't know, did I submit? Yeah, I submitted.